A very good afternoon. Thank you for joining me here today. I am Anupama Tiruvaipati, a senior software engineer at Bloomberg. For those who are unfamiliar, Bloomberg is a global leader in finance data, news, and technology. I am part of a buy-side product called AIM, which stands for Asset and Investment Manager. AIM helps investment professionals manage their portfolios, ensures compliance, and streamlines their trading workflow. Now, as the title says, fixtures meet parameters, writing efficient, elegant, and reusable test. We are going to spend next 20 minutes, just a moment. Yeah. We are going to spend next 20 minutes diving exactly into that. How to write clean, effective, and reusable test using the power of fixtures and parameters. We'll also talk why test usability matters, not just to save time, but to also ensure that our test suites are more scalable, more reliant, and easier to evolve when the system changes. Just to clarify, when I'm saying parameters, I'm referring to both @pytest parameters for different test inputs, and also the params options, which is used inside the fixtures to run the test across multiple setups. These two together unlock some powerful patterns. So for this talk, I'll be using a hypothetical service called trade booking. It'll illustrate for our ideas. As the name suggests, this service is responsible for booking trades, and it also handles some complex workflows. This will serve as a backdrop for everything that we are about to explore. Good. This is our trade booking service, a well-designed and structured. It includes a request handler, adapters, builders, and it also contains some critical logic for fields like price, quantity, settlement date, and many more fields. I'll just say that this service is written with some of the good principles in mind, such as clean design, well-tested workflows, strong architectural boundaries. Later, we started getting more requirements for our service to expand its functionality. What began as a tiny enhancement quickly evolved into something much bigger, which we called the project as the Blue Whale project. Later, our product found a client who wanted to integrate to our system, but they wanted the same core functionality with more structured input. So after many discussions, we agreed to introduce a new API, which accepts much richer and more flexible data. If we talk about tests for a moment, we don't really have textbook-defined unit tests, such as test client A, test client B, test validate timestamp, test validate price. Why? The entry point for these tests were at the lowest possible level, which made them extremely brittle. They were granular and tightly coupled to the implementation. Even as the simplest refactoring, such as renaming a method or moving a function around, could break a dozen of tests. This diagram shows what I mean. Most of our unit tests were scoped too narrowly. They ended up deep inside our code, checking internal functions and missing out the bigger picture. So don't worry, what we do have and what worked really well for us are behavior-driven unit tests. These tests don't deep dive into isolated functions or internal implementation details. Instead, they start high up in the stack and focuses on the system's behavior, how it responds to a real use case. Here are some of our behavior-driven unit test examples. Test duplicate trade is rejected. Test trade timestamp is UTC normalized. Test trade buy side has a positive impact on positions. These tests are powerful, not because they're complex, but because they align with the intent. They describe what system should do and not how it's built on. And the best part, they survive refactoring. As long as the behavior doesn't change, these tests don't break, even if the underneath code is completely reorganized. Here's a diagram that shows just how high up a behavior-driven test actually starts. By starting at this level, they avoid the entanglement with the internal mechanics and instead focuses on the user-facing behavior, which ultimately matters the most. And that's exactly why these tests remain stable, expressive, and resilient, even as the implementation underneath them continues to evolve. Here's one of our behavior-driven tests in action. So we have test trade by side has a positive impact on positions. This test explains what we care. If a buy trade is booked, then the position should go up. The input is just a side and a quantity. And the output, a single meaningful assertion about the change in positions. So let's quickly recap our product requirement. So we agreed on the new API with the same behavior, but with new structure. And we had to ask ourselves, what about the test coverage? We had few options. Option 1, rewrite. This means rewriting all the existing tests to point to the new API only. That might work if your service was deprecating the old behavior, but that's rarely the case. So if your system is still supporting both the old and the new versions, and rewriting only to point to the new behavior leaves the old behavior completely untested. It's a bit risky. Option 2, ignore. We could ignore the new API and continue testing for the old one only, since we said the behavior is almost the same. By ignoring the new changes means we are not testing the new input at all. It leaves us vulnerable to subtle bugs that arises from how the new data is being passed, validated, or mapped. Option 3, duplicate. We could duplicate the entire test suite, one for the old API and one for the new API. We will have the full coverage, but also double the test code and double the maintenance, and a growing risk that our test will drift apart over the time. Let's quickly rate these options. Option 1, rewrite. It sounds simple, but then it's incomplete. We're forgetting about the old behavior, and that's risky. So we're going to call this as a bad idea. Option 2 is ignore. Honestly, this is one of the worst. It assumes that the new structure will just work out of the box without having any testing. So a very bad option. Option 3 is duplicate. At first glance, it looks safe because we get the full coverage for both the APIs, but it comes at a high cost. Imagine duplicating 2,000 unit tests. Now, maintaining two identical suits is very hard. It's exhausting, it's error-prone, and not scalable at all. So we're going to call it a very, very bad option. So after weighing all these options, this was it, the moment of truth. We had to decide how we wanted our test suits to grow with the product, not just to survive the change, but to thrive with it. And the answer was reuse. And how did we do that? By combining the power of fixtures and parameters. Instead of rewriting or duplicating, we kept our existing behavior-driven test and just made them flexible enough to support both the APIs. Before we go too deep into the mechanics, let's take a quick look at the basics. First up, pytest parameters. This is one of the simplest and most powerful tools in pytest. It lets you run some test function multiple times with different input and expected output. So instead of writing 5 similar tests, you write once and you run multiple times with different scenarios. You can even assign IDs to make each test case more readable in the output. It's especially helpful when you're trying to debug a long test suite. Next up, fixtures. A fixture in a pytest is a reusable setup code. It helps you set up the world that is required for the test, such as a user, a mocked service, a trade, or anything that's required for the testing. So it helps you set up, it helps you with the setup and with the teardown, if needed. So you can stay focused on what you're testing and not how you're preparing for it. So we got our basics refreshed. I'm going to walk you through a 3-step approach to reuse behavior-driven unit test. Step 1, we start at a higher point by abstracting our setups, by abstracting the difference between the APIs behind a common interface. On the top right side, you can see old API setup class, which is having a couple of methods to update fields like quantity and price. And just below that, we can see new API setup class with the same methods, but it's targeting different variables. We'll come back to this in a moment. But if you look at your left side, to unify the interfaces for both the APIs, we introduce the swapper class, trade booking test setup. It takes either old API setup or new API setup and forwards the method calls like update quantity and update price. This means that our logic, our test logic, does not need to care which API it's interacting with. It only talks to a single and a consistent interface. And this is where Python's duck typing come into picture. If it walks like a duck, quacks like a duck, then it's probably a duck. So as long as our setup object responds to the right method, then we are good. No inheritance, no base class, and no, just the behavior. So let's zoom in and see what actually is being set under the hood. In old API setup, we actually take fields like quantity and price, and they are the two fields that are getting set. And in case of new API, the same concepts are stored in fields like traded quantity and negotiated price. This difference may seem small, but for a test, that's a direct impact. It's a breaking change. So by abstracting these details behind our trade booking test setup, we allow tests to focus on the behavior, and while the setup handles the structural difference between the APIs. Step 2, it's time to create fixtures. Now we wrap both of our setup into their own fixtures. These fixtures instantiate the appropriate setup class and let us inject into our tests. The fixture name matters in this case because that's how the pytest knows what to inject. It's effectively the reference point for calling the fixtures. Now, it's time to put all together. We got our behavior-driven test, we got our setup abstractions, we got our fixtures, and now we are ready to reuse these tests across both the old API and the new API. And here's what a test class looks like. First, let's take a look at this. We are defining a fixture using @pytest fixtures and a list of parameters, and in this case, it's old API and new API. This tells pytest that run every test in this class twice, once with the old API and once with the new API. It's a simple change, but then it gives us a huge payoff, reuse without duplication. Now let's talk about setup method. In pytest, setup method is a hook method that runs before each test in the class. And we use it here to inject the right version of the test setup, depending upon which parameter is being passed. And that's how we dynamically bind the workflow to either old or new behavior. Here's, you can see the full view of setup method function. So this one line is doing all the magic. It grabs the right fixture and it sets to the variable called self.workflow. So from this point onwards, the rest of the test code is going to only refer to self.workflow, and it does not really care which API it's interacting with. So yeah, before we go ahead, I would like to take a moment to talk about the get fixtures value. It's a lesser known but very powerful pytest feature because we are sending our parameter list is made of fixture names. This basically allows you to look up for fixtures using name without any hard coding or keeping things flexible. Here's the beauty of our shared setup. No matter which API you're using, we can just call self.workflow.updateQuantity. And behind the scenes, this update will either go and use the variable update for old behavior, and in case of new behavior, it will update the trade quantity field. Now we take one step further by combining fixture-based setup and parameterizing the input. Here's the test that we have seen earlier, which was talking about the buy trade. Now we're going to add one more scenario for the sell. Now this test runs for both the API setup, old and new, and multiplies the test scenarios for buy and sell. So from a single test, now we get four full test cases, each validating the behavior and not the structure. This is the end goal. The tests are efficient, elegant, and reusable, no matter how many APIs or use cases we have to support. So, why does all of this matters? Because the reality of engineering is that we are always changing things. We migrate to new APIs, we refactor, we deprecate, or we simply just evolve over the time by adding more functionality. But tests, they often get left behind. And when they do, we are left with redundant test code, brittle assertions, and a long list of failing tests that do not reflect about actual failures. So here's what I hope you take away today. Write tests that describes what the user expects and not how the code works under the hood. Write with the correct structure, such as fixtures, parameters, abstractions, so that your test becomes an asset and not a maintenance burden. They evolve with your code base and instead of fighting against them. And at the end, combine fixtures plus parameters to scale your test suits elegantly. Thank you, and may your test be meaningful, maintainable, and never mocked beyond recognition. And if Thank you. And if you're interested in behavior-driven testing, you can check out my earlier talk. Thank you.
Thank you so much, Anupama, for that informative talk. And moving on, do we have any questions for Anupama from the audience? Does anybody have any questions? We also have a Discord channel where you can post your questions. Yeah.
You mentioned this in your talk, apologies, but is there a behavior-driven design framework or anything like that that you like to use? Any tools around that?
No, I can't think of any frameworks in particular, but it's more of the way that we include the TDD/BDD into our testing as well. So instead of just writing the plain test, which only talks about, let's say, a function or like a tiniest part of your code, we prefer writing it with a behavior or a workflow to be very specific, so that it leaves like an inline documentation, and also it will help us to understand what exactly or like how exactly it'll impact the clients. So I can understand most of the time if you're writing with in a big architecture where you have multiple microservices, not every service is a client facing, but then in some way they do give an impact, right? So just we talk about that instead of just the inputs and the outputs.
I have another one if nobody else has one.
Go ahead.
Cool. So in the last talk, just before yours, the guy spoke about the testing pyramid a little bit, and he was like, cool, you need just a few integration tests because they're slow, and then at the base of the pyramid, you need lots and lots of unit tests. and that's a standard thing, but that's not something that you follow. Is there, so you do follow something like TDD, but you don't do those fine-grained tests. When you hire new engineers onto the team, how do you, how does that discussion go? Because I imagine it can be quite contentious.
So I'm not saying that we won't have any more tests. No, we do have lots and lots of tests.
No, but I mean the basic, like testing individual fine-grained functions. You said that you avoid that because it
Yes.
becomes very brittle.
Yes.
Yeah.
So what we do is, instead of going individual function, we just start at a higher point and we mock out all the third-party dependencies. Like, is there any library usage or anything else? We just mock out everything, and then we will be having, like, that's the, I would say, behavior-driven unit test, like I said in the talk, and then we'll be having like end-to-end component or service level test, and then we'll be having integration tests, which are actually talking with all the services. So there'll be like different kinds. I'm not saying that this is going to replace all of your other testing. So no, think of this like an onion. So each layer is going to be like a peeling off, and then each layer we'll be having tests. So this is like the innermost one, the most basic one, so that you get like a fast feedback loop. So you just run, and then within a couple of milliseconds, should be less than 10, I should say, you should have all of your tests done.
Okay, cool.
Yeah.
I think this works. Okay, good. So just like you said about being an onion, I was just curious in how you do this behavior unit test with evolving data in terms of, like, let's say you have an input as a data frame, you're doing some business logic, right? And you have an output of what you expect that business logic to do. So would that fit in the data-driven unit test, or would that be more so tightly focused unit tests that you want to avoid?
I didn't really understand. Could you repeat your question? Sorry.
Yeah. So, for example, if you had like a input for like a data unit test, right? So you have an input like a data frame. You have some logic that the code does,
okay.
and you have an output of the data frame that the logic should do. So basically, it's like kind of the behavior, but it's really focused on that logic itself.
I understand, yes.
Yeah.
I think you can still write a behavior-driven test, because if you think of this from not as an engineer who's writing the code, but then zoom out a little bit, it's still taking something as an input and something as an output. It's producing, right?
Right.
So ideally, the way I see this is, as our BDDs and DDDs explain that we should talk about behavior, then you can say, even in the data intensive application where it's taking inputs from the framework, it'll just take about one key, let's take the same example, like a price or a quantity. If that was an input and you're mapping it to something else and producing another huge JSON, then your output can say, oh, you know what, I have this XYZ behavior, and this particular key is mapped to something else. So you can still write in that matter.
Okay.
Yeah.
Thank you.
Still doable.
Any last questions? I can't see if you can raise your hand. Anybody? Okay.
Cool.
Thank you, everybody, for joining us today for this talk. Thank you, Anupama, for that wonderful talk. And please give her a loud round of applause for the talk.
Thank you. Thank you, everyone.
Thank you all.